This problem is slightly modified from the example that we did in class on Wednesday. The example that we did in class had a power of 2 in the denominator. So we're not going to do that problem. We're going to do a simplified version. I want to show you how to work with solving for the coefficients. That's what we want to do, is solve for the coefficients when you've got 3 unknowns. Okay. So let's see here. So this is our partial fraction decomposition form. And again, our first step in order to evaluate this integral is going to be to solve for the coefficients a, b, and c. So let's go ahead and do that. So if I know that 2x minus 1 divided by x times x squared plus 1 is equal to a over x plus bx plus c over x squared plus 1. On the right hand side, I'm going to rewrite this like so. My least common multiple is going to be x times x squared plus 1. And in the numerator, I'll have a times x squared plus 1 plus bx plus c times x. Okay? And my thought process around that is I look at a and I say, what do I need to multiply x by in order to result in x times x squared plus 1? So that means I need to multiply the top and the bottom by x squared plus 1. X squared plus 1, right? And then over here, for bx plus c, I need to multiply the top and the bottom by x. Now I've got the common denominator and I can just add the numerators, okay? So any way that you do that is fine. It's just, you just want to make sure that you don't make a careless error, because then that'll mess up your problem, right? That'll mess up the entire problem. All right. So now I essentially have the following equation. I have that 2x minus 1 over x times x squared plus 1 is equal to this, right? But this is equal to the right-hand side. So I'm going to put in here a times x squared plus 1 plus bx plus c times x over x times x squared plus 1. I've got the left-hand side is equal to the right-hand side, and the numerator and the denominators are equal. So it must be that the numerators are equal. So 2x minus 1 is equal to a times x squared plus 1 plus bx plus c times x. So I'm going to expand the right-hand side, so I have a x squared plus a plus bx squared plus cx is equal to 2x minus 1. Combine like terms, a plus b times x squared plus cx plus a. Okay, so now here's where some students have difficulty, because you say, now how do I know what to set equal to each other? Okay, pretend like this is 0x squared plus 2x minus 1. Right, that's kind of the best way to think about it. So now, the x squareds have to match up, right? Because on the left-hand side, if this is a polynomial, the graph of it's going to be a line, right? Y equals 2x minus 1. And the right-hand side has to be a line because they're both the same thing. Then a plus b better be equal to 0. So that's one equation I have, is that a plus b is equal to 0. And then I do the exact same thing for the coefficients of the of x, right? If 2x has to be equal to cx, so c must be equal to 2. And then the same thing for the constants. -1 has to be equal to a. And now that I know that a is equal to -1, I can plug that back in to my top equation and say that b has to be equal to 1. Right? So b is equal to 1. So now there is actually a kind of like a little shortcut method, and I want to show you that shortcut method to solving for your coefficients. Copy, paste. We're going to pretend like we didn't just do it the long way. So here I am. I'm at this step right here. So here's what I say. I stick in values for x, right? So the idea is I've got a line, right? So if I have 2x minus 1, which looks something like that, this is a crappy sketch, right? But so say this is y equals 2x minus 1. And then on the right-hand side, I've got something, I don't know what it is, right? But what I can say is, when x is equal to 0, the left-hand side is equal to -1, right? So when x is equal to 0, 2x minus 1 is equal to -1. If 2x minus 1 is the same thing as this a times x squared plus 1, then that means that when I plug in x equals 0 on the right-hand side, I should also get -1. So if I plug in x equals 0 on the right-hand side, I'll get a times 1 plus, right, if I plug in x equals 0, that's going to be 0. So this whole back term is going to disappear. So I'm just going to get a plus 0 is equal to -1. So that makes my life, this simplifies things because right off the bat, I know that a is equal to -1. Okay, and now I can say, well, if a is equal to -1, let's kind of repeat this. So now 2x minus 1 is equal to -x squared plus 1, right? Because remember, now I know that a is equal to -1, so I'm substituting -1 for a, and I can say plus bx plus c times x, right? And so then I can, let me just kind of factor this or expand. So I have -x squared minus 1 plus bx squared plus cx is equal to 2x minus 1. Okay? And actually, in fact, I didn't need to do that. Another thing I could do is plug in what happens if x equals 1/2, which is the same thing as going back to this graph here and saying what happens, right, when x is equal to 1/2, y is equal to 0. So when the left-hand side is equal to 0, the right-hand side has to be equal to 0. So if x is equal to 1/2, 0 is equal to negative, now what's 1/2 squared plus 1 plus b times 1/2 plus c times 1/2. Right, so I can get equations perhaps more quickly than equating coefficients. So that'll be 1.25, negative 1.25 plus 0.25b plus 0.50c is equal to 0. And then I would test another point, maybe plug in x equals 1, right? If x equals 1, then the left-hand side is going to be 2 times 1 minus 1. So 2 times 1 minus 1 is going to be -1 squared plus 1 plus b times 1 plus c times 1. So I'd have here -2 plus b plus c is equal to 1. So b plus c is equal to 3. Right? And so between this equation here and this equation here, I've got 2 equations, 2 unknowns, and I can solve for my unknowns. Okay? So either way you do it, you're going to end up getting your solving for your coefficients, and that's what you want, because that is the essential part of step 1, right? Solve for the coefficients a, b, and c. So let's go ahead and clear all this away. but don't erase our our answers. So what we found out is that, so we found out that A is equal to -1, B is equal to 1, and C is equal to 2. So, so A is equal to -1, B is equal to 1. 1 times that, and C is equal to 2. Okay. So, the integral of 2x minus 1 over x times x squared plus 1 dx is equal to the integral of -1 over x plus 2 over x squared plus 1 dx. So the first thing I'm going to do is split up these integrals. So negative integral 1 over x dx plus the integral of x plus 2 over x squared plus 1 dx. All right. The first integral should be straightforward. It's negative natural log of x. And for the second integral, you've got a couple of different ways to do it. You could split it up first. So here's one way to compute the integral of x plus 2 over x squared plus 1 dx. One way to do it would be to say we're going to let u equal x squared plus 1. Then du is equal to 2x dx. So, well, I guess for this problem, there's just pretty much one. This problem isn't going to show you the technique that I wanted to show you. So we'll ignore this part right here. And for now, let's go ahead and plan on just working with this precise example right here. Let's actually go ahead and split this integral up one more time. So x over x squared plus 1 dx plus 2 times the integral of 1 over x squared plus 1 dx. Okay? And now we can write negative natural log of x plus, we're going to do a u substitution. If we let u equal x squared plus 1, then du is equal to 2x dx. So we'll have the integral of 1/2 the integral of du over u. And then at the back here, we should recognize this as arctangent of x. Let me put plus a constant. And now let's go ahead and evaluate this. This will be 1/2 natural log of u. But, so let's see, arctan x plus a constant. U really was x squared plus 1. So we'll have negative natural log of x plus 1/2 natural log of x squared plus 1. And then plus 2 arctan x plus constant. And remember, the one last step we can do is to combine these first two summands using our properties of logs, and we will get the natural log of the square root of x squared plus 1 over x plus 2 arctangent x plus a constant. And that's our final answer.